Hi, students and friends. This is your host and teacher Sayyid Ayazuddin Haider, and you're watching Learn and Teach by Sir Ayaz. So, I will continue my video session for past papers. This time, I have selected IGCSE 0620, and the variant is 61. It's of October November 2023. Paper 61 is paper 6, that's alternative to practical. The time is 1 hour. You have to answer all the questions, and no additional materials are required. You may use a calculator. In information, the total mark for this paper is 40. Notes for use in qualitative analysis are provided in the question paper. It will be like this. Okay, there are tests for anions, cations, gases, as well as flame tests. Let's start the paper straight away. Here's question number 1. A student uses chromatography to analyze samples of 3 different dyes. The apparatus the student uses is shown in figure 1.1. So here's the figure. You see in this you have beaker in which a paper is dipped, and they have labeled the baseline also. A. A spot of each dye is placed on the paper and some ethanol is poured into the beaker. Draw on figure 1.1 3 spots in the form of dots to show where the 3 dyes are placed on the paper at the start of the experiment. Dye number 1, dye number 2, dye number 3. In this way, you are going to place the spots. A line to show the level of ethanol in the beaker at the start of the experiment. Now, the solvent level, it should be below the baseline. Here's the baseline. You see the baseline should be below the baseline and not touching any of the spots. In this way, you will draw it. Use scale for this purpose. Part B. During the experiment, the ethanol moves up the paper. State when the student should remove the chromatography paper from the ethanol in the beaker. When the ethanol is almost at the top of the paper. Part C, figure 1.2 shows the result of the chromatography experiment. State what conclusions can be made from this result. If you look at this result, straight away, you can write the statement. These all dyes are soluble. This can be one of the statements or conclusion you can draw. And if you look at dye 1 and dye 3, they only contain one color, which means they are pure substances. And in case of dye 2, it must contain dye 1 and dye 3, because if you look at the spots obtained in dye 2, one of the spot matches the distance covered by the spot in dye 1, and the other one, it matches the distance covered by the spot in dye 3. So you can write any two from these. Any two from these. All of the dyes were soluble. Dye 1 and dye 3 are pure substances because each contain only one color. Dye 2 contains di 1 and di 3. Moving to next question. Question number 2. Copper 2 carbonate reacts with dilute acids to make carbon dioxide gas. Malachite is a mineral that contains copper 2 carbonate. A student investigates the rate of reaction between powdered malachite and dilute ethanoic acid at different temperatures. The student does 6 experiments. Experiment number 1. Use a measuring cylinder to pour 40 centimeter cube of dilute ethanoic acid into a conical flask. Warm the dilute ethanoic acid by about 5 degrees centigrade. Measure the temperature of the acid using a thermometer. Set the apparatus up as shown in figure 2.1. Is figure 2.1. Remove the bung from the conical flask and add 1 gram of powdered malachite to the conical flask. Replace the bung and start a stop clock. Record the time taken for 100 centimeter cube of gas to be collected in the measuring cylinder. Empty the conical flask and rinse it with distilled water. Now student further carry out more experiments. That's experiment number 2, 3, 4, 5, 6. Now what is the difference between this? In case of experiment 2, warm the dilute ethanoic acid by about 10 degrees centigrade. In case of experiment 3, warm by about 15 degrees centigrade. In experiment 4, warm by about 25 degrees centigrade. In experiment 5, warm by about 35 degrees centigrade. In experiment number 6, warm by about 40 degrees centigrade. A. Use the thermometer and stop clock diagrams to complete table 2.1. Now for experiment 1, if you look at the reading, it must be 26.5. What about the time? If you look at the time, this is second, which means this one is of second, and this one is minutes, which means that's indicating minutes. So if you'll count the minute, 1, 2, 3, 4. So we have 4 minutes, and for seconds you have 30 plus 42. It means 42 seconds. So you have to show the reading in seconds. So 4 minutes mean you have to multiply 4 by 60. So what you will get? 4 multiplied by 60, because 1 minute means 60 seconds. 4 minute means 4 multiplied by 60, you will get 240. 240 plus 42. 282. 282 is the seconds here. Now experiment 2, if you look at the reading, it must be 31. What about the time? Now the minutes, it's showing 1, 2, 3. 3 minutes. We have 3 minutes. 3 minutes means 3 multiplied by 60. What you will get? You will get 180 seconds. 180 seconds. What about seconds? We have 15 seconds. So you will add 15 to 180. So it must be 195 seconds. Number 3. You look at the reading, 35, 36. So it must be 36.0. What about the time? For minutes, we have 2 minutes. 2 minutes mean 2 multiplied by 60, 120 seconds. What about seconds? Must be 28 seconds. So add 28 to 120. What you will get? you will get 148 seconds here. Experiment number 4, 41, 42. It must be 42 degrees centigrade. What about the time? If you look at the time, it's 1 minute. 1 minute means 60 seconds or 60 seconds. But what the second? For second, it must be 45, 46, 47, 48, 49, 50. So 60 plus 50, you will get 110 seconds. Now, experiment number 5. If you look at the rise in temperature, 51, 52, 53, 53. What about the time? Time shows 1 minute or 60 seconds. Plus, how many seconds? You have 1, 2, 3, 4, 5. So you will have add 5 to this, so you'll get 65 seconds here. The last one, 55, 56, 57, 58, 59, 59.5. It must be 59.5. What about the time? So second, minute is 0, which means 0 second. And for the seconds, you have 44 seconds. So I will write 44 straight away. So these are the readings. B. Complete a suitable scale on the y-axis and plot the results from experiment 1 to 6 on figure 2.2. Draw a line of best fit through your points. So you have time taken to collect 100 centimeter cube of gas S and the temperature of ethanoic acid on the x-axis. So we have 26.5, and you have to show seconds also. So what I will do, take this as 50 second, then you have 100 second, 150 second, the y-axis, 200 seconds. After 200, you are having 250. And the top, you are having 300 seconds. This will help us. Okay, the first reading, it's the rise in temperature is 26.5. So if you'll count, you'll have 26.5 here. 1, 2, 3, 4, 5, 26.5. We have 26.5. It must be here. And the time, it's 282. 282. So it must be here. 60, 70, 80, 90. Between one spot must be here. Next reading, 31. 31 means here. And seconds is 195 seconds. 195 second means 50, 60, 70, 80, 90. 195 means it must be here. 195. So it must be here, the second spot. Now you have 36.0. 36.0 must be here. What about time? 148. 148 means you must be having 10, 20, 30, 40, 48, 48. It must be here. Next one, 42. 1, 2, 42. And the seconds, 110. So 110 means straight away. Yes, this must be the spot. And then we have 53. 1, 2, 3, 53. 53. And the time is 65 seconds. 65 second means 50, 60, 65. It must be here. Yes, this must be the spot for 65 seconds. And the last one, 44 seconds. You have 59.5. 59.5, it must be here. 44. 44 means now you have to draw a line. You have to draw a line, appropriate linear vertical scale. So you have to plot all the points correctly. It would be like that. This will be the final graph. See, the average rate of reaction in an experiment can be calculated using the equation shown. Average rate of reaction, volume of gas collected, time taken to collect the gas. Part 1, use this equation to calculate the average rate of reaction. Experiment 6, give the units for the rate you have calculated. So how much gas is calculated? The time, total time is 282. 282 seconds is the total time. The volume of gas collected is 100 centimeter cube. So 100 centimeter cube in 282 seconds. The time taken to collect the gas is 282. So if you have 100 centimeter of the gas collected in this total time of 282 seconds, so how much volume will be collected per second using this equation? Point 0.354 centimeter cube. This will be the average rate. 0.354 centimeter cube per second. Number two, deduce in which experiment 1, 2, 3, 4, 5, or 6 the rate of a reaction is greatest. It's obvious the highest temperature is in experiment 6. So experiment 6 must be the experiment in which the rate of the reaction is greatest. D, extend the line on your graph in figure 2.2. Reduce the time taken to collect 100 centimeter cube of gas when the temperature of the ethanoic acid is 65 degrees centigrade. 65 degrees centigrade. So here's the temperature. 65 degrees centigrade means 1, 2, 3, 4, 5. This is 65 degrees centigrade. If you'll extend it, the time, the time must be 1020. So you must be having time must be 20 seconds. The 40 centimeter cube of ethanoic acid used in each experiment is measured using a measuring cylinder. Measuring cylinders are available in the following sizes: 10 centimeter cube, 25 centimeter cube, 50 centimeter cube, 100 centimeter cube, and 500 centimeter cube. Draw a circle around the size of measuring cylinder which would be most suitable to measure 40 centimeter cube of ethanoic acids. Definitely 50 centimeter cube because the volume is 40 centimeter cube. If most of the gas collected in the measuring cylinder is air rather than carbon dioxide, number one, explain why air is collected in the measuring cylinder. Because its displays are pushed out of flask by carbon dioxide. You can write displaced by carbon dioxide. Part 2. Explain why this does not affect the accuracy of the results. Now, the volume of air displaced is the same as the volume of CO2. Volume of CO2, that's why. So G, during each experiment, the temperature of the acid decreases slowly. Give a reason why the temperature of the acid decreases and suggest a change to the apparatus used that would minimize the decrease in temperature. The reason is that heat is lost to the surrounding, or you can say flask is not a good insulator. Anyone from heat lost to the surrounding. Flask is not a good insulator. Oh, change to apparatus. You can place it in water bath or insulate the flask. Place in water bath. It should be kept at the starting temperature of the acid. It's very important. Moving to next question, number 3. A student tests two substances, solid M and solid N. Test on solid M. Solid M is hydrated chromium 3 nitrate. Complete the expected observations. A. The student places half of solid M in a boiling tube and heats it strongly. 1. The student holds a piece of anhydrous cobalt 2 chloride paper at the mouth of the boiling tube. Observations. Remember, if you heat this hydrated salt, so what will happen? It will produce steam or H2O. And this cobalt 2 chloride paper, it is used to test water. Used to test water. So initially its color is blue. It will definitely turn to pink because it's anhydrous. It becomes hydrated when water is added. Water becomes part of this salt, cobalt 2 chloride. So you write blue, from blue to pink, from blue to pink. In the part 2, the student inserts a glowing splint into the mouth of the boiling tube. The splint bursts into flames. Identify the gas given off by heating solid M, which causes this result. It must be oxygen gas, so you write O2 here. Okay, part B. The student dissolves the remaining solid M in water to form solution M. Number 1, the student adds aqueous sodium hydroxide dropwise and then in access to solution M. Observations during dropwise, adding dropwise, and observations in access. If you see, it's a chromium nitrate, chromium 3 nitrate, and look at the result. Let's look at the result of the cations. So here's the cation. We have, where is chromium? There is chromium 3 plus. So it must be with aqueous sodium hydroxide, green PPT, which is soluble in access. So you will write dropwise green PPT. In dropwise, you will write green PPT or precipitate. Observation, soluble or dissolves in excess. Soluble or dissolves in excess. Number 2, the student adds a piece of aluminium foil to the product from B1. The mixture is then warmed. The student tests for any gas produced. Observations. So if you look at this salt, it contains nitrate ion, and the test for the nitrate ion, it's an anion. Here's a nitrate ion. The test is you will be adding aqueous sodium hydroxide and then aluminum foil. Warm carefully. You have already added sodium hydroxide. Now you have added aluminum and warming it, which means the gas produced must be ammonia. So the test for ammonia gas. So ammonia gas, it turns damp red litmus paper blue. So what you will write, simply observation. So they are saying observations. So definitely the test you have to write down the test. Damp red litmus paper turns blue. Damp red litmus paper turns blue. Test on solid N. Table 3.1 shows the test and students' observations on for solid N. Do a flame test on solid N. Light green flame. Test 2. Dissolve the remaining solid N in water to form solution N. Divide solution N into 4 portions. To the first portion of solution N, add dilute sulfuric acid, white precipitate. Test 3. To the second portion of solution N, add about 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous silver nitrate, pale yellow precipitate. To the third portion of solution and add about 1 centimeter cube of dilute nitric acid followed by a few drops of aqueous barium nitrate. No visible change. To the fourth portion of solution and add about 1 centimeter cube of aqueous chlorine brown solution. Part C. Describe how to carry out a flame test. Now they are asking the procedures to carry out flame test. First of all, you will use a wire or splint. Use a wire or splint to get the substance into a flame. So put the sample into flame. Put sample into flame. And identify Bunsen flame. As blue or non-luminous, should be hot, blue or hot. De-identify solid N. Now if you look at these tests, the first one they are saying light green flame test. Let's see the light green color. It must be barium, Ba2 plus. Must be Ba2 plus. And there's a white precipitate with dilute sulfuric acid. It's not indicating any result. We don't have any. And the second part, what they are saying, you're adding nitric acid followed by aqueous silver nitrate. These are the tests for the halide ions. If you look at the test for the anions, so you have the test for the halide ions here. Chloride, bromide, and iodide. Here's a test. And you see yellow PPT for the iodide. It must be having iodide present in it. In the third portion, they are saying they have added dilute nitric acid followed by a few drops of aqueous barium nitrate. Aqueous barium nitrate is used to test sulfate ion. Where is the sulfate ion? Here's the sulfate ion and barium nitrate. So it must be absent. No visible change means SO4 minus 2 absent. To the fourth portion, add about 1 centimeter cube of aqueous chlorine. Now they have added chlorine. So chlorine is more reactive than iodine. It must displace iodine. If it will displace, so here's a reaction. If you'll pass chlorine with the iodide salt, you will get what? You will get iodine plus chloride ion. Let's balance the equation. So this iodide, it's indicated by this brown color. It gives brown solution. So it means iodide ion must be there beside Ba2 plus ion. So identify solid and you will simply write Ba2 plus and I minus. That's it. Number 4, grease away and kitchen clean are two solutions used as household cleaners that contain aqueous ammonia. Plan an investigation to find which of the two household cleaners contains aqueous ammonia with the highest concentration. Assume the aqueous ammonia is the only alkali in the cleaners. Include in your plan the method you will use, how your results will be used to determine which household cleaner contains aqueous ammonia with the highest concentration. You are provided with common laboratory apparatus and chemicals. Now they are saying ammonia is the only alkali. So definitely you will go for the titration method. So you can write any six of these, any six from. These are very easy steps. You will start with the stated or known volume of cleaner. Stated or known volume of cleaner. It's containing the ammonia. Then mention the apparatus. You will get 1 mark for this. Name the apparatus. Used, like you can use pipette here. Definitely in the titration you will use pipette for transferring alkali to a conical flask. Then you will use measuring cylinder also. And it's a titration reaction, which means you are going to use acid. And for the acid, you will take acid and burette. So I've write burette here. So now you have to use some kind of indicator. Name the indicator you are using in this experiment. Name the indicator. Use like phenolphthalein or methyl blue. The next point, add the acid to cleaner through burette to the flask. Add acid from burette to the flask. It's actually conical flask. Containing cleaner. Then note down the correct endpoint colors. Correct endpoint colors. For example, if you have used phenolphthalein, so it must be giving a pink in cleaner and colorless in acid. So you are adding acid to the cleaner, so the endpoint must be pink to colorless here. In this case, pink to colorless. Record or measure start and readings. Record the readings. Initial and final. Next point, definitely higher volume of acid used means more concentrated ammonia. Higher volume of acid used means more concentrated ammonia. So you can write any six from these. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.